So we're given this trapezium here, and we're asked to show the area is given by this expression here. Well, if you think about the formula for the area of a trapezium, it's A is equal to a half the sum of the parallel sides times the distance between them. And here we don't know the distance between them, the vertical height, but we could use Pythagoras just here, and we would get that this side would be the square root of 9 minus x squared. Note that the 3 is the hypotenuse. So the area is going to be a half. Sum of the parallel sides is x plus 14. And then the distance between them is the square root of 9 minus x squared. So that's going to be a half of 2x plus 14, square root of 9 minus x squared. And of course we can factorize 2x plus 14 to give us 2x plus 7. And so that would cancel, the 2 coming out would cancel with a half. And therefore we have x plus 7, the square root of 9 minus x squared, which is exactly equivalent to what we've got here. So, moving on. Given that x can vary, find the stationary value of a. In other words, what we want to do is differentiate this and find when it's 0. So, a is equal to x plus 7. And then that was 9 minus x squared to the half. So if we want to differentiate that, it's a product. So we can say that u is equal to x plus 7 and v is 9 minus x squared to the half. So du dx is equal to 1. And dv dx is going to be a half. 9 minus x squared to the negative a half, multiplied by the differential of the inside, which is negative 2x. So negative 2 and then a half, so we're just going to have negative x, 9 minus x squared to the negative a half, which is minus x over the square root of 9 minus x squared. So dA dx is going to be v du dx, so that's this one multiplied by this one, so that's just going to be the square root of 9 minus x squared, plus u dv dx, so that's that times that, and with this minus here it's going to become a minus, so we'll have x plus 7 over the square root of 9 minus x squared. And we want when that is equal to 0. So the square root of 9 minus x squared, take away x plus 7 over the square root of 9 minus x squared is equal to 0. So the square root of 9 minus x squared would be equal to x plus 7 over root 9 minus x squared. Multiplying both sides by the square root of 9 minus x squared gives me 9 minus x squared is equal to x plus 7, which we can expand out like so. And if we bring everything across to the right, so we're adding x squared here, so we have 2x squareds. Got plus 7x, and then it will be minus 9 is equal to 0. So can we factorize this? Let's hope so. So we've got 2x and x. And so if we have 3 and 3 won't do it. So if we have 9 and 1, and this one's a plus and this one's a minus, that will do the trick. And so we get x equals negative 9 over 2 or x equals 1. And this one here is not possible because at the very beginning x was a length and a length can't be negative. So we have that x is equal to 1. So we wanted the stationary value of a. So a, remember, is x plus 7 square root 9 minus x squared. So a, when x is 1, is equal to 8 square root of 8. And I'm not sure we'll get pinged for this, but root 8 is root 4 root 2. We should write it as the simplest possible surd is my point. That would be 2, so it's going to be 16 root 2.